You all for the data structure class. Today we will move to the next part of the binary search tree, that is the deletion operation. If you want to delete a particular node in the leaf node, it is very simple. Just you delete that node from the tree. Okay, so that time what happen, parent node left side child value will become null. Okay, if you want to delete the non-leaf node, that is intermediate node, if you want to delete the node intermediate having only one child, it is very easier. So at that time what happens, if you delete the intermediate node, then that node's child will be directly linked to the upper node. Okay, so see here 5 is the intermediate node, so it is having a child 2. So when you delete 5, 2 will be added to the root node 30. Okay, it is very simple. Suppose if you want to delete the non-leaf node which is having a 2 children, how it can be perform the operation? Either you replace the left node to the intermediate node, or right node as the intermediate node. So see here if you want to delete the 40, left node you are having a 35, right node you are having 80. Either you can replace with the if you delete 40, you can replace with 35 or 80 as the intermediate node. Okay, so this is how you are performing the deletion operation. So we'll see with the function how it can perform. Okay, initially your root node is null, your tree is empty, you are returning the value. Okay, if root node is not null, what happens? Your current node is what? Root node. Okay, and your current node is not null. At that time, whatever the insertion your item you are doing, if you are delete the operation item, if it is equal to current node information break, then your deleted information is nothing but what? Parent node. Okay, if your item is less than, then you are moving to the left part of the tree. If your item is to the greater than, then you are moving to the right part. Okay, if current node value is null, it indicates that item is not found. Okay, if current link value is equal to null, then what happens? You are connecting that node to the root node. Okay, otherwise you are connected to the right node. Okay, similarly the successor value of the current link you go on connecting, okay, to the left node or the right node, and finally you are returning the root node. Okay, this is about the deletion operation. Next, how you are performing the maximum value in a binary search tree. Okay, initially your root node is null, then you are returning root. If not, current value is root node, current R link value is not equal to null, then you have to go on tracing the current R link value, because as you know, in the binary search tree, the right part of the tree will be containing what? The largest value. So until you found the last value, you go on finding the current R link value. So finally last value you are returning, that is the current value, that is the maximum value in the finite tree. Similarly, if you want to find the minimum value, at, as you know, the binary search tree left part of the tree is always having a minimum value. So at root node is null, returning. Else if you are going to the current L link value is not equal to null, you go on tracing into the left node, last leaf node, so until you find the lowest value, then you are returning that current value. Okay, this is for what? Minimum value. If you want to find the height of the tree, what happens? First you are checking what? Root is null, return -1. Else your return is what? 1 plus maximum height, that is root L link or R link. You are go on tracing. Maximum is what? Either A or B, left or right. So you go on tracing and you find the height of the tree. Next, if you want to find the counting the number of nodes in the tree, how you are performing? If root equal to null, then you are returning. If root is not equal to null, then you are counting root L link value, go on counting, and you are incrementing the count value. Okay, so this is how you can count the number of nodes in the tree. Okay, next, if you want to count the number of leaf nodes, what happens? If root is equal to null, then you are returning. If not, count leaf root L link value checking, and you go on incrementing the counter value until the root L link and R link values become null. You go on checking and you are incrementing the count value, and that it determine how many leaf nodes you are having in the tree. Okay, binary search tree. Okay, so you seen with the what? Deletion and application. What is height, maximum value, minimum value, number of nodes, and counting the number of leaf nodes in the tree. Okay, so in the next video I will be uploading what? Applications of a tree, that is expression tree, how you are evaluating. Okay, so that is the last bit of the fourth module. So we will be completing the fourth module. Okay, and later I will be uploading assignment questions also. Okay, thank you.